All right, I think most of the class is already here. Am I right? Okay. Good day, everyone. Sir John here, and welcome back to another discussion of chemistry. Okay, our subject chemistry. So today we are going to have a conversation about the polymers and its uses. Okay, but before we'll proceed to the discussion, I would like to request all my students to please comment your name, your complete name, and your course, including your section for you to confirm your attendance for today's class. Again, for my students, please comment your complete name and your course in order to confirm your attendance. All right, so with regards to your attendance, you can comment while we are about to start our discussion or after our discussion. It's up to you. Okay, pwede og before magsugod mo comment or after sa discussion mo comment. Okay? So, please get your notebooks, your papers, and your ball pen for you to take down notes about our discussion this day. All right? Because um, we will get some of the points here, okay, which will be included to our quiz this Friday. All right. Okay, I think we are all set. Okay, once again, good afternoon, good day, everyone. So, this day we are going to talk about the polymers and its uses. Okay, wherein we are going to emphasize as well the different problems that might arise with the use of the polymers, and we are aiming to understand the plastic recycling symbols. All right. So, from the Stone Age to the age of the computers, a significant development is self evident in the materials that make our daily life comfortable. One of these revolutionary materials is in the modern world is the polymers. Okay, people have been using polymers for thousands of years, but they just don't recognize it. Okay, if we'll try to look at everything that we use right now, almost all things that we have is later on we are going to know what really a polymer is. But the bags, the plastics, the shoes, okay, your shirts, okay, including some parts of our body, okay, is a polymer. So later on, you will know what are those things. So what is a polymer? What is a polymer? Polymer is a molecular compound with high molar mass formed by repeated linking of small molecules called monomers. Again, a polymer is a molecular compound with high molar mass formed by repeated linking of small molecules called the monomers. Okay, so it is a combination of the Greek words poly, which means many, and meros, which means parts or units. So it can be defined as any class of natural or synthetic substances composed of a very large molecules, which are multiple of simpler chemical units called monomers. Okay, so basically, when we say polymer, it is the combination of the monomers. Okay, so it is the linking of the small molecules called the monomers. So that means that the basic unit for the polymer is the monomer. Okay, now the process, okay, by which the monomers combined and transformed into polymer is known as polymerization. Okay, so again, the process by which the monomers combined and transformed into polymers is known as polymerization. polymerization. So monomer plus monomer, that is equals to polymerization. Polymer, I mean. And the process itself is called polymerization. Okay, so this idea, okay, of polymerization was proposed by this person, Hermann Staudinger, who received the Nobel Prize in 1953. Okay, so this is the picture of Mr. Hermann Staudinger. Okay, so he is the person who proposed polymerization. Okay, so according to him, according to Mr. Herman, okay, there are two types of polymer. So we have the homopolymer and the copolymer. So let's talk first about the homopolymer. So homopolymer is a polymer made up of only one type of monomer. So you just need to remember this phrase, only one type. Okay, so that's the only thing that you will remember for homopolymer, only one type of monomer. It comes from the prefix homo, which means one. Okay, again for homopolymer, one. Okay, next we'll proceed to the copolymer. So for cop again, it's not copolymer, it's copolymer. Okay, again, it's copolymer. See, the copolymer is a polymer made up of two or more monomers. So it's more than two. When the monomer is more than two, okay, it's called copolymer. Okay, it's very understandable because of their prefixes. Okay, when we say copo, I mean co, we say co, that is more than two. Okay, all right. So I hope that's clear. So I have here some monomers and their synthetic polymers. All right, so these were the monomers, the building blocks, and if we are going to combine this monomer, we can have the polymer. And also in the table, you can see its corresponding uses. How did we use this, okay, in our society? So let's start with the first one. The first monomer is the ethene. Okay, so when we combine ethene, okay, we form polyethylene. Okay, and okay, the use of polyethylene is for us to make bags and films. Next, we have caprolactam. Okay, again, monomer caprolactam. Okay, if combined, we can create a polymer called nylon 6. I know most of us are familiar with this because we see this, we can see this at our houses or in most places that we go. Okay, so we use this polymer to create fibers, brushes, and ropes. Okay, next monomer is esters. Okay, so from this monomer we can create a polymer called polyesters. Okay, so esters creates polyesters. Okay, and its use is for synthetic fibers. Next, we have the monomer vinyl chloride. Okay, the monomer vinyl chloride forms the PVC. Okay, I know you are familiar with the PVC. You use it for your pipes at your houses. Okay, so it creates the monomer vinyl chloride creates the polymer PVC or polyvinyl chloride. So its uses is for PVC tubes. Next, we have tetrafluoroethene. Okay, the monomer tetrafluoroethene forms a polymer Teflon. Okay, it is used as parts of electrical devices, coating vessels, and Teflon coating. Okay, we use Teflon oftentimes when we connect something or we want to seal something. Okay, Teflon is good to use. Next, we have the monomer chloroprene. Okay, chloroprene can create a neoprene, okay, and it is used nearest to the natural rubber, okay. So it can be a substitute of the natural rubber, okay, a household and medical articles. Next, we have ethylene chloride and sodium tetrasulfide, okay, which is a monomer. Okay, when we combine these two monomers, we can have the polymer called thiocol. So it's basically the example number seven is a copolymer because it's more than two. It's two and more. So it forms the polymer thiocol. Okay, so I'm sorry. The thiocol is used for gaskets, seals, and hard rubber articles. All right, I hope that's clear. Okay, so the polymers play a very important role in human life. Okay, it makes up many of the materials in living organisms and are the basis of many minerals and man-made materials. Our body is made of a lot of polymers like the protein, enzymes, and many more. Other naturally occurring polymers like wood, rubbers, and etc. The first synthetic polymer was invented in 1869 by, okay, John Wesley Yacht. Okay, he is the first person to make a synthetic polymer. Okay, so he made that as the first substitute for the ivory balls. Okay, what is an ivory ball? So the ivory ball is the ball that they used in the ancient time to play the game billiard. Okay, are you familiar with the game billiard? I know most of us, okay, especially boys, are quite familiar with this game, billiard. In this game, we have to shoot a ball, okay, and that ball was being replaced by Mr. John Wesley Yacht with a synthetic polymer to make it more efficient to use. Okay. All right. So it was not until in 1907 when a polymer entered the industrial sector with the invention of the bakelite, the first fully synthetic plastic containing zero naturally occurring molecules. Okay, so all right, so it is being developed, okay, in 1907 when the polymer is entered the industrial sector. Okay, so this time, let's talk about the types of polymers. Okay, there are different types of polymers. Aside from the main classification, which is the homopolymer and copolymer. Okay, we have also the so-called natural polymer. Okay, natural polymers. When we say natural polymers, they are obtained from natural materials. Okay, it comes from the nature, the tree, okay, the animals, the biotic thing, okay, the natural things. Okay, so for natural polymers, we have proteins. You are familiar with proteins. Where can we mostly find protein? Okay, yes, it's commonly found in the meat. Okay, meat, legumes, okay, fishes. Okay, so that's where we can find the proteins. Okay, the polymers of amino acids. Okay, so the protein is the polymer of amino acids. So the monomer, that means that the monomer of protein is called the amino acid. Okay, so it plays a key role in nearly all biological processes. Okay, so it's basically used for the building block of our muscle and for us to have energy because proteins can be a substitute of our energy if wala na ang carbohydrates. Okay, next to protein is nucleic acid. Okay, so the nucleic acid is a polymer of nucleotide, which means that the monomer of the nucleic acid is called nucleotides. Okay, complex molecules composed of containing bases, sugars, and phosphoric acid, which play an important role in protein synthesis. Okay, the thing that we can see, okay, in our DNA and RNA. So that those were the examples of nucleic acid. Okay, we have the deoxyribonucleic acid and the ribonucleic acid. Okay, next to nucleic acid is we also have the cellulose. Okay, so cellulose is also a polymer. Okay, it's a polysaccharide actually. Okay, it comes from the monomer saccharide. Okay, or monosaccharide. Okay, so it is the main structural units of plants. Basically, the cellulose is found at the leaves of the plants. Okay, cellulose. Okay, we have another uh, natural polymers as well, aside from cellulose. We have rubber. Um, okay, we have rubber. We have silk, we have wool, and we also have cotton. Okay, those were other examples of natural polymers. Aside from proteins, nucleic acid, and cellulose, we also have rubber, silk, wool, and cotton. Okay, so next to natural polymer is the synthetic polymers. Okay, so from the word itself, synthetic meaning to say it is created. Okay, it is made by human. Okay, so polymers which are synthetic, okay, is synthesized in the laboratories or factories. Okay, human-made polymers often derive from petroleum oil. Okay, mostly it comes from petroleum oil. So some of the common examples for synthetic polymers are the following. Okay, first we have polyethylene. Okay, polyethylene. Later on, we are going to talk more about these examples because we commonly use these things. However, we just don't know that these things are actually polymer. So later on, you will identify what are those things that we use which are actually a polymer. Okay, next to polyethylene is polyester. Okay, next, acrylics. We also have polyvinyl chloride or PVC and also rubber. All right. Now, let's take a look and further discuss some of the most commonly used synthetic polymers in our daily life, which are mostly plastics. Okay, plastics are made from raw materials like natural gas, oils, or plants, which are refined into ethane and propane. So the ethane and propane are then treated with heat in a process called cracking, which turns them into ethylene and propylene. Okay, these materials are combined together to create the different polymers. Okay, so it's basically from the monomers. Okay, the polymers comes from the monomers, but it just undergo a process. So let's talk about them one by one. Let's go first with polyethylene. Okay, polyethylene. So the polyethylene is also known as polythene, as what we've mentioned a while ago. One of the most prominent plastic polymers, accounting for 34% of the total plastic polymers. Imagine 34% of the total plastic polymers. And when we try to look at the things that we have right now, almost everything is plastics. Okay? Mga plastics na kasagaran ang gigamit, and 34% of that is polyethylene. 34%. So it's a lightweight and durable thermoplastic with a crystalline structure and a general chemical formula of C2H12. H4 times N. Okay, its properties includes high ductility, high impact strength, and great chemical resistance. All right. So I have here the different types of polyethylene or polythene. Okay, these are the different types of polyethylene or polythene. So the first one is called low density polyethylene or LDPE. Okay, this is a semi-rigid translucent polymer with a high degree of long and short chain branching monomers, which lowers the density of the polymers. So meaning to say this is better compared to other types of polyethylene because of its property. Okay, it is a useful plastic for molding and extruding shapes. The most common use of LDPE is in manufacturing of plastic bags that we use to carry items, manufacturing of various containers, dispensing bottle like the shampoo bottles, tubes, plastic parts for computer components, and various molded laboratory equipment. Okay, so those were just some of the uses of the low density polyethylene. Okay, next we have also linear low density polyethylene or LLDPE. Okay, so the LLDPE replaced the use of LDPE for plastic bags and sheets, allowing for lower thickness and almost equivalent efficacy. All right. So other items made of LLDPE includes transparent films, scratch packaging, bags, toys, lids, caps, pipes, cables, and many flexible tubing. Okay. Next to LLDPE is we have high density polyethylene. Okay, high density polyethylene. Okay, or HDPE. As the name suggests, it is a high density thermoplastic because of its linear structure and no or low degree of branching. Okay. Due to the absence of branching, it has a strong tensile strength and chemical resistance, making it a preferred resistance is an ideal combination of strength, cost efficiency, and environmental friendliness. So, if we want to create something that is durable, is that is you would most likely use high density polyethylene. Okay, the HDPE is good for that. Okay, so those were the different types of polyethylene. Okay, next to polyethylene is we have ethylene terephthalate. Okay, polyethylene terephthalate. Okay, so the polyethylene terephthalate is typically called polyester. Familiar with the polyester? Okay, so it's called polyester when used for fibers or fabrics. Polyester fibers are often mixed with natural fibers to create a fabric with aggregate properties. Okay, as compared to natural fibers, the polyester fibers have superior water, wind, and environmental resistance. Because of these properties, it makes it ideal for garments and jackets that are to be used in wet or damp environment by coating the fabric with a water-resistant finish. So we don't know that maybe some of your clothes that you have is made from polyethylene terephthalate. Okay, so when used for bottles, okay, if bottles, jars, containers, and packaging applications, it is called PET or PET resin, okay, or polyethylene terephthalate resin. Okay, So PET is the world's packaging choice for many foods and beverages because it's hygienic, strong, lightweight, shatterproof, and retain freshness. So it's very good to be used for the packaging of food. Okay, kung gusto kag very quality na packaging sa food, the PET is a good choice for you. Okay, so this is the example of a PET, very durable. Okay, and of course it is recycled, which is good for the environment. Okay, so 90% of PET in the US, okay, that goes to the recycling bin is recycled. Okay, pwede nindot siya i-recycle because this this thing becomes broken. Okay, dili siya dali maguba. Okay, so next we have acrylics. Okay, I know we already use acrylics. It's also known as acrylate polymers. Okay, so these materials are commonly known for their transparency, resistance to breakage, and elasticity. These properties make acrylic extensively useful for application requiring high transparency and impact resistance. Some of the common uses includes acrylic nails, acrylic paints. Okay, this is commonly used. Acrylic paints, LCD screens, and acrylic home decors. Another acrylics includes cyanoacrylate resins made into fast-acting adhesives such as super glue and pressure-sensitive adhesive. So, indeed, acrylics is very useful. Okay, so I want you to remember, don't forget to remember the different applications or uses of the following polymers that I have presented. Okay, remember its uses. Okay, next to acrylics is the PVC. Okay, familiar with the image? Okay, so the pipes that you use at your houses is called PVC, is from the polymer PVC. Okay, the PVC is a high-strength thermoplastic material. It is produced by polymerization of vinyl chloride, okay, which is the monomer of the polyvinyl chloride. It has replaced several conventional building materials such as wood, metals, concrete, rubber, ceramics, and others in a variety of applications due to its versatile properties such as lightweight, durability, low cost, and ease of processing. Okay, aside sa barato siya, it's also lightweight, okay, gaan, and it's also durable compared to some materials that we commonly use. Okay, di ba? Um, when we buy wood, okay, it's very expensive. Expensive ang kahoy ron. Okay, depende po sa kahoy. Especially kanang mga endangered nga plants, endangered na mga kahoy, it's a very expensive. It's very expensive. That's why to save the money, okay, for you to save money without risking the durability of the material, okay, the outcome, okay, the polyvinyl chloride is a good option for that. Okay, PVC pipes have replaced the metal pipes used for household distribution of water. Indeed, reducing the risk of contamination via corrosion. Why? Kay kanang atong mga pipes, most of our pipes right now actually use the PVC, the polyvinyl chloride. Why? Okay, because if we use, kung sa unang mga panahon that we use The metals nga mga pipes, mostly tayan siya. Okay, marust siya, and it if it will become oxidized, it creates rust, which may contaminate the water, which is not good for our health, of course. So the PVC is commonly used as an insulating cover for electricity wires, network throughout the house, manufacture of sliding doors and window frames that are extremely durable, affordable, and help conserve energy when heating and cooling homes. In fact, the vinyl windows have three times the heat insulation of aluminum windows. Meaning to say, dili siya dali kaayo nga mainit compared to other materials. So it also plays a critical safety role in dispensing life-saving medicine through intravenous bags and medical tubing. Also, one-third of plastic-based medical materials are made from the PVC. Okay, kanang dextrose, kanang sudlanan sa bags sa dextrose. Most of that is made from the polyvinyl chloride because it's safe. Okay, next to polyvinyl chloride is we have polypropylene. Polypropylene or PP. Poly, not proly, it's poly. Polypropylene is one of the most versatile and cost-effective polymer. It is produced via chain growth polymerization propene monomer. What's the monomer of polypropylene? Okay, it is propene. Okay, ang yung monomer is called propene. It is used in the infrastructure of microwave safe containers because of its higher resistance to cracking and stress. Okay, the same thing sa inyong makitaan sa image, which is a pipe. Dili siya basta-basta ma-crack. Dili siya basta-basta ma-huba. Okay, the PP is ideal for tough and robust products like protective car bumpers. A large volume of it is utilized in the fabric industry. So PP fibers is utilized in a host of applications including tape, draping, and staple fibers. Okay, for marine applications, PP ropes are twines. Again, PP ropes and twines are used as they are very strong and moisture resistant. Okay, so that is the polypropylene. Next to PP is, okay, this is very familiar to us. Okay, the rubber. Okay, rubber. Rubber is an elastomer, a polymer that is primarily characterized by its ability to regain its original shape after being deformed. Okay, we use rubber, of course, if we want to tie something tightly. Okay, a rubber is good to use. Aside from its stretchable property, good. It's also a good thing to use because it it does not welcomes oxidation. Okay, so dili siya matayan. There are many different kinds of rubbers, but they all fall into two broad types. So naay duha ka broad nga types of rubbers. We have the natural rubber and the synthetic rubbers. Okay, so for natural rubbers, they are harvested mainly in the form of the latex from the rubber tree with the scientific name Hevea brasiliensis or other plants. So just remember that when we say natural rubber, okay, it comes from something coming from nature, okay, like the tree. On the other hand, when we say synthetic rubbers, they are made in chemical plants. So they are being processed. They are laboratory made na mga rubbers. One of the most commonly known synthetic rubber is the neoprene, okay, which is chemically known as polychloroprene. Okay, the neoprene has a good chemical stability and maintains elasticity over a wide temperature range, making it a preferred material for the manufacture of wetsuits, wrists, and orthopedic knee braces. Okay? Surgical gloves, laptop sleeves, mouse pads, and gaskets. Okay, kanang itabo na to sa i-protector sa atong mga gadgets, i-protector sa keyboard. Okay? Most of the companies also use rubber. Okay, another popular family of synthetic rubber is the styrene butadiene rubber or SBR, which is widely used for